All right, so just going to get into a few different things. Monopoles, nuclear fusion, nuclear fission. Well, nuclear fission, nuclear fusion. The a priori, a priori, the a priori evolution. Conjuncture right now. I'd say uh well, objectifiably what it is. Especially this value equation. If you're valuing sentience as life and all that, and you believe in sort of this Darwinian evolution, you can't really have a priori in terms of well, we're proving nuclear fission and we're proving nuclear fusion, and therefore that objectifies that we proved the Big Bang. So that makes no sense at all since you have no actual. I mean, you're just saying you have theoretical evidence that we can create the assumptions that we have on the phenomena of the universe to be able to, uh, I mean, just just lie that we have the solution for evolution or the creation of evolution, like all of the ingredients of evolution. It doesn't make any sense because you can't recreate evolution. So that's I'll try to get into that. Heisenberg, Schrodinger, some more like a little bit of their equations. I know that Heisenberg is just a lot of wave equation. It seems like, and also Faraday seems to be a lot of like wave, beta, duality, the radius squared paradox thing, and then yeah, Faraday basically takes you all the way to Maxwell, and Maxwell takes you into the Bohr atom. And then once you get into the Bohr atom, you're basically stuck with either Heisenberg or Schrodinger. Um, so Heisenberg kind of gives you like a consecutive pushing magnetism, and Schrodinger basically gives you like an infinite number of angles to bend you could say the lines of the magnetism. So anyway, um, yeah, I was gonna say too, I really hate Thanksgiving. I do. I hate Thanksgiving. I would never prioritize one human over another, and the fact that in this global economy, that's exactly what we do. We just prioritize our neighbors over our overseas neighbors, and that's all we are really capable of. And you can put the veil over your eyes if you're in one of these sadomasochistic relationships or what have you or whatnot, and you just forget because you have to prioritize human beings and things like that. So now we're all at the position of, or the first world is all at the position of like just Hitler, in the caves with the starving Jews, and just like 120 days of Sodom, like just having starving Jews or starving children or whatever, just um sadomasochistically fuck each other, and that's like their form of entertainment. And now we all have that form of entertainment basically. Well, some people do the child pornography thing and they get locked up. Okay, I mean, like, all that shit is really bad and all that stuff. But yeah, I mean, it happens in other countries. It seems so much more. It seems so much more likely to happen in other countries since there is such a lack of prioritization on uh, I mean, it's partially the Europeans' fault because the European again builds up their economy and just gives them absolutely nothing, or they still live in this really diabolical monarchy like they do in Africa, or there's just insanity like there is with the cartel in South America. So these things are all persistent and real, but we don't really see it as that. We just see it. It's all digitized to us, and then you have like this other holiday called Christmas, and it's supposed to be like this. This everybody knows it's this bullshit Christmas thing, but I mean like why celebrate it or why think that it's a good thing. I mean, these things just bring people together to drink and all this stuff and sort of bullshit and tell their little fake stories and all that. And I mean, you have like just too many overbearing stories. Like, I mean, you have jingle bells and the little cats. Like they used to put cats. Uh, they used to put like bell collars. Okay, you can make like bells out of just metal, and you can put it and you can lace it through a collar, and you can put that collar on a cat, and then you'd always know where your cat was. And the little jingles, um, supposedly used to scare away ghosts and all this shit, or they used to scare away spirits, spirits, demons, whatever. And so there's this whole like satanic thing where Satanists hate cats because Satanists like those. The whole Satanist thing. It might be like an Aleister Crowley sort of persistence, like persisting on the teaching that cats are evil somehow. But like you just put little bells on the cat, and it scares away Satan because Satan's Santa Claus and all that stuff. It's like the Satan Claus. Um, it has a lot to do with like the story of has a lot to do with the story of Jesus and Satan and how Satan's going to give Jesus the world and Jesus doesn't accept the world, and now you have this Satan clause where yeah you just get free presents, free presents, and that's sort of considered the world. So Satan is technically giving you the world, and so that's the oblique esotericism or zeitgeist and all that bullshit. But I mean, the there's the astronomical there's the astronomical alignment where the sun doesn't shift um out of position, or we're in a certain gravitational pull of our elliptical, where the sun doesn't move for 3 days. So not too good at astronomy. I don't know if that happens in the southern hemisphere, but basically you have Satanists who want to kill cats because they like Satan, and yeah, the jingle bells warns you that Satan is coming. So the cats are supposed to walk around and warn you that Satan's coming, but the Satanists kill the cats so Satan can be free. Um, I'm just saying, in the whole like I don't know, like why prioritize America is founded off of genocide and then celebrate the exact holiday that is kind of in con that is in, kind of in contrite with that is kind of contrite with that genocide. Okay, so you're celebrating like the genocide of Native Americans. So I don't get it. I think it's horrible, and none of these other countries celebrate it, and so it's just stupid. Um, yeah, it's just stupid, and yeah, I don't know, I've got my head all up I've got my knickers all in a bunch because just these girls, and um, I had like a I had like a I don't know, like a soft restraining order placed on me and all this stuff. So I don't know if she's listening or not, but yeah, I don't really want to get into it. But it was like a soft restraining order, so I didn't get into any trouble or lose any benefits or anything. But I got to be careful with that. Like there's no point in me even talking to girls. I mean, I should really get like a I should just really get a tattoo on my forehead already, like it says asshole or whatever, and just stop talking to girls. So yeah, yeah, monopoles. I rarely hear them talked about. They do seem to be extremely important in nuclear fission. Okay, nuclear fission nuclear fission, you could say, was at the beginning of this Big Bang theory. Uh, that's why the electrons and the protons and I don't even know. You're talking about fusing the nucleus together because it's nuclear fission, and you're trying to fuse the subatomics together. But at a certain temperature, that's not even possible. So the only way it's possible to obtain the fusion and actually fuse sort of these misaligned electrons and misaligned neutrons, sorry, protons, these electrons and protons that are all sort of in just some abstract geometry. They could have maybe like a little bit of magnetism between them and create squares or triangles or circles or X's, like a PlayStation. And those bars of magnetism can hold them together and do enough. So that's the idea. They're not really they don't have um they don't have any uh well they don't have any fusion yet, so they don't have any exact shape. Their shape is not fused together. They don't have these orbitals and or these elliptical orbitals or whatever they're talking about in the atoms, and all this stuff is um it's all next to impossible. I mean, it's all impossible to prove. I'll say that all these subatomics, again, all of this Bohr stuff that came since like the 1830s. So it's like from the 1830s to the 1930s, you finally get like your atom, and before that, all you have is the apple fell from the tree. So, and then all of a sudden, you have this atom, okay, which is a lot like your Adam and Eve. It's like bullshit. Um, it's just bullshit that they called it the atom, and the first human is supposed to be Adam. Like that doesn't make any like does that make any fucking sense at all? I mean, could they be like more open about like their colossal like syphilis disease that they're trying to spread? Like they're practically yelling that we have syphilis, come get some syphilis. So yeah. Anyway, yeah, so you have like this sort of, I mean, the theory is that you have these little bars that are connecting through magnetism, and they can't form their nuclear pattern, which would just be circles and orbits and all that. And it's just because the temperature is too high, and then as the temperature cools and cools and cools, that's when they're actually able to fuse. The protons and the electrons are able to fuse. And then you have like you might have like your nucleus has to have well you have your protons, but then you also have to have like your positive and negative charges. So before your positive and negative charges are just either they're just forming shapes, triangles, squares. I said circles, but I didn't mean circles. Like some sort of like just a straight line. And so these all have to be positive and negative, but there can, it seems like they're open to like a contingency on whether or not it's positive and negative. So it can sort of be either. They can sort of be dynamical like that. Uh, but then you get into this nominal theory, this basically this Schrodinger Bohr stuff, where you have now like as you're cooling, I don't know if it's 20 billion Kelvin, to around like our sun, maybe 5 billion Kelvin, or it's getting to 5 million Kelvin. Um, Either way, they're just zeros, and their temperature, but it's all nice. But I mean, it's a nice theory, but it's going to have to theoretically work in the world of calculus or mathematics, and that's what I have a problem with. But I'm just saying, you have this cooling effect, and now you're getting into nuclear fission. And of course, I wasn't really emphasizing that when you have your monopoles, your a monopole would be like just a positive charge floating in the air. Sorry, a negative charge floating in the air, and the negative charge would attract the positive charge. So the positive charge would see the negative charge. You could say the positive charge is what you should say. The positive charge is an electron. Could you correct me if I'm wrong? And the negative charge would be a proton. And so you're saying these monopoles would exist in this fission, and the fission is when the temperature is too high. I mean, I also would like to say, like, yeah, we say that we have nuclear fission plants and nuclear fusion plants, and somehow that theoretically, somehow according to this a priori, that we have these nuclear fission plants, like these nuclear fission plants somehow they can generate. I mean, is that the idea that they can somehow generate the temperature at the beginning of the Big Bang? And you're telling me the temperature at the beginning of the Big Bang is like way hotter than the sun? I'm not going to believe it. They also have nuclear fusion plants, or they could be one and the same. And these are basically just these are basically just melting. I mean, these are just plants that are melting metal, and they're melting metal and refining the metal. Like they're just melting metal or creating plastic. I mean, because you can throw oil into like extreme temperatures and you can bake it and then you can bake it and or you can like basically cook it and turn it into a liquid and then you can let it dry and then you can cook it again and that's how you create plastic. So these are like this is like the nuclear plant thing, like they're just either creating plastic or um whatever. Yeah, sorry. Yeah, I mean I guess I'm just taking bounties and trying to uh whatever proselytize to the cavemen or whatnot. But I mean, I'm not trying to, get too much in the commentary, but yeah. I mean, I had something good I was going to talk about, but I mean, you had like the Jello. I think Cambridge posted about the Jello yesterday, and there were, this Jello aspect. I mean, all you're really doing is again just to make plastic. You just have to um basically uh fission, fusion, fission, fusion, fission, fusion, uh, carbon or oil, crude oil, whatever, what have you. And yeah, that's how you get plastic. And so yeah, it's a little bit ridiculous how they use the language and all that stuff. But I mean, then you have this a priori evolution where the statement goes that I think Sean Carroll I think he's saying that the statement goes is that we have these fusion plants and we have these fission plants, so why don't we have? So isn't that evidence for having our Big Bang? Isn't our Big Bang evidential if we can fizz and fuse particles like plus and minus or electron and proton particles? Isn't that evidence that we are sort of recreating the Big Bang? I would say absolutely no, it's not. Although the Big Bang might have the right idea. Again, it's just this guideline, it's this outline, it's our best simulation, it's our best concurrent form of how matter could be created, how the elements could be created, and it works well, especially with the Bohr atom, which is the little orbit, because once the fusion happens, then that's when they gain the orbit, and that's when electrons and protons. We're talking about more. We're just going to be talking about more and more fission happening. Okay, so fission gets all the way to carbon, which is six protons. I think six protons, six neutrons, six electrons, and so we're talking about a lot of fission. Okay, we're talking about a lot of fission because monopoles can only exist in the hottest of temperatures. So when that fission happens, that cooling effect happens, then well, the cooling effect happens, and that means that there's more particles, there's more bits um, within one, you could say, jurisdiction of orbits or neutrons and electron or protons, neutrons and electrons, and the more particles that those fit, the more solid. I mean, it goes from gases to liquids to solids. Um, and of course, combinations of those can create different liquids. Correct me if I'm wrong, but that seems to be like that's my assumption on the periodic timetable. But there's combinations of those elements can hybridize and all that stuff. Uh, but yeah, I mean that's no concrete evidence for just because a brain is a lot like like plasticity. Just because a brain has plasticity and we can recreate a jello that feels and looks like a brain doesn't mean that it is an operating brain, is what my point is. So you're not recreating that, you're just creating examples, not examples, that's not the right word, but models. Okay, so all these things are models. And yeah, once you get back to your Heisenberg, like you're sort of stuck because the magnetism is just operating in one direction. I mean, it's sort of it's sort of denouncing the Faraday paradox, saying that the magnetism or the energy is going to go back in, or it has to go in. It has to go in to the conductor to be able to send out the conductor. But I mean, the real idea, okay, and also the idea of catching lightning. If you were to catch lightning in a bottle, um, there's going to be like an extreme amount of magnetism that creates like extreme amount of static uh, electricity, almost what you could just say is an abundance of magnetism, like an abundance of this, what is it called, fission. Okay, so this nuclear fission is happening where um, where the electricity where the lightning strike is going to take place. Okay, there's a huge amount of fission that is heating up and heating up. So that means, and not only that, but it's grabbing more and more bits. It's grabbing more and more particles, electrons, and protons, and it's sucking them. It's kind of sucking them into a vector, like a vector that's going to go straight up to the sky, right? But there also has to be. It's not exactly, I don't know. I don't think it's exactly going straight up to the clouds, like per se. Like it doesn't have to do that like by default, but you could just say from the ground to the clouds, there is a huge mass of there's a huge fission that is collecting, and this this is kind of my point that proves the alternating current. That it's just alternating current. Am I saying that wrong? Sorry, it's just direct current. So it's just going to be one direct current from the ground basically to the cloud. And, if you have that alternating current, then you have, uh, I don't know if the right language is like, rubber or something that, like rubber. I mean, like, what does rubber do? Like, you're supposed to like get in your car if there's a lightning storm because there's going to like because your car tires are made of rubber, and rubber is it's the opposite of a conductor. It's not a conductor. So I don't know what the right. I guess you could say it like rubber could be an insulator. Okay, so rubber's an insulator because you could say that it holds geometric unity. So it actually holds geometric unity because it has been fused. Okay, so it has been fused and the cooling has happened. Um, but when you have something like a tree, like a tree might get hit by um, lightning. Okay, I'm not really saying that lightning strikes like go all the way up to the sky and then come back down and hit a tree. I wouldn't really believe that. I would say they might go up in the sky a little bit and then they might find a tree to hit. But a tree, um, or especially like an antenna, like a satellite antenna, um, is something that um, is something basically that a direct current of electricity would want to connect with because these are also direct, you could say they're direct currents of magnetism or electricity, whatever you want to call it. Because a tree is carbon and it's doing photosynthesis and stuff. I don't really need to get into all that, but like, I mean, especially like an antenna, it has to have, I'm not saying that it's entirely, um, I'm not saying that it's entirely a direct current. I mean, I think it would have an obvious, I mean, I think when, you say that and the satellite's plugged in and everything, and you got your satellite and it's going to or sorry, your antenna's going to the satellite, then yeah, it has a direct current it has a direct current to that satellite. That means it has, uh, I would say that it has nuclear fission going on. It has like this lack of geometric unity within its protons and electrons, and that's how it's able to create uh, this line to the satellite, and the satellite can convert. The satellite also has a direct current to another bigger satellite on Earth, and that bigger satellite on Earth, they'll have different programming, and that programming has little, microchips or film that is gathering the stations, and then those stations go to the satellite, and that satellite sends those stations to the antenna, or all the antennas abroad, like the satellite in the sky that connects to the ground satellite will send a bigger wave, um, a really, like a really big direct current to these other satellites, and those satellites will pick up on that. So, nothing miraculous there. But I'm just saying, that's how you can kind of look at a lightning strike. It's fissioning, so it's fission, 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 and all of the and it's gather and it not only is it doing that, but it has the rhetorical, for lack of a better term, anatomics, subatomics in its like field, and then it collects more and more electrons and protons, positive, negative, but they're fizzing, so they have a lot of fission, and and then you could say when they gain enough fission, they're able to actually, you could say that it's a form of fusion. When they're actually able to fuse together, then that's when they're able to like send it off. Um, like the fission process is sort of this induction that it doesn't collapse, but it collects more positive and negative charges, and those charges eventually fuse, and that nuclear fusion sends a direct current um, to whatever point it needs to best connect with, depending on where the magnetism was showing. So by magnetism I mean the electrons and protons. Um, and then of course it's over. Okay, so it was one direct current from the ground to the cloud, and then of course it's over. And after it's over, uh, there's nothing left. There's no, it's not an alternating current. Okay, like there's no light switch on the lightning is what I'm trying to say. So the Faraday paradox as well, there like should still be magnetism left over after the lightning strike. Like it's like after the fusion, Okay, and you could kind of say that's like the Big Bang thing. And so after the fusion, there's like this remnants of the lightning strike. So the fusion happened, like the fission, the nuclear fission happened, the lightning strike went up, so that was the fusion, and then somehow there's still this remnants of bits or particles, and that's supposed to be what's left over. So that's like the Faraday paradox because they say that there's a transfusion. So when you have a alternating current and you have a generator and the you have the magnetism and let's see here, you have the magnetism and the you have the um like a coil that heats up and magnetism, and then you just have this fan that cools down the coil or the magnet, and this can be ran off a generator, and this generator will precipitate the fan, and there can also be another well just a fan. Well, I think the fan heat and cools at the same time, so the turning of the fan would um, it would grind and grind until the coil got so hot that it actually created energy, and then the energy would go into the magnetic plate or the conductor, or I guess the conductor, and then the conductor would be attached to the fan, and the revolutions of the fan would just heat it up and cool down at the same time, and the energy that you would get from the generator, that generator would that generator would that generator would lead to that generator would have even yet another conductor, and that conductor would be able to induce electricity, um, because eventually you'd gain enough voltage or wattage, and essentially there should be like a thermometer that says, well, the generator doesn't need to cool down anymore, so the generator just shuts off. And then when the generator needs to turn on again, I mean, there's going to be a bunch of generators, but this particular generator, the smaller generator, it'll have like a thermometer on it and it says, okay, I don't need to cool down anymore, so it just turns off by itself. Um, but that'll have an alternating current to another generator, I would imagine. But this generator, when it needs to produce when it doesn't have enough electricity, then it'll start producing this electricity through this cooling fan, and this fan at the same time will grind and grind and grind and perform the the magnetism, and then the magnetism will be conducted by a plate, and then the plate will be connected to this fan and all that, and then so it'll be able to send watts of energy. Okay, it'll be able to send watts of energy, and those watts of energy can be connected to your TV. But your TV is also going to have be connected to an antenna, and the antenna will also be connected to the satellite, and the satellite will be connected to another, massive ground satellite and all that. So that's kind of my idea on that. But I mean, I'm just saying. So multiple there's going to be multiple alternating currents, pretty much, that are efficient, that are able to run efficiently off of one um, direct current. Okay, and this is and this process of the direct current is basically the nuclear fission, and the nuclear fission is what is doing it. Okay, but they want to say that the nuclear fission is a product of the creation of the universe, and that is just Captain Insano.